to be a good act. I've got it on good authority. So over to you, Hannes.
Is that the first question coming up, I see? Traditionally, the data center is a bunch of bricks and mortar that you throw together, mix it around, and get something up. You throw a bunch of servers inside, and voila, you have a data center. Good afternoon, ladies and gentlemen. My name is, as she mentioned, Hannes Stein. I look primarily after the HPC, the big data, the high performance data analytics, and the artificial intelligence environment for Intel in the Sub-Sahara region. So basically everything data center related falls into my lap to talk about, look at, provide solutions at the end of the day, and scope solutions. So what I'm going to take you through today is the challenges the data center face. Traditional data center, as I mentioned, just doesn't cut it anymore. The workloads these centers face are changing dramatically, and with that, what you put in a data center and how you apply that data center has to change. So, what we refer to is the vortex that is closing up on the data center environment. There you can see, what is a vortex? Quite a nice description you get in a dictionary. A whirling mass. I like the people how they can play with words. An irresistible force, a powerful current, but all of that is true. Now, today I have to condense a 1 hour typical presentation into a 20-minute slot, so I'm going to leave out quite a few of the things I normally talk, and I'm going to cover 3 areas basically. The challenges the data center face, an overview of 3 key solutions out of the many that we have, and then the killer app for the future that's going to have a dramatic app on the data center as you know it. So, the data challenge. Data is the new oil. This is just a picture to scare you a bit of what's coming and the challenges from a sheer amount of data the data center face. Yes, it's huge numbers. I don't worry about remembering those, but it's just an indication of what certain type of workloads, what they are going to put on a data center. An interesting one for me, and I'm going to talk a bit further about that, is the autonomous vehicles. 4 terabytes of data a day per car, per autonomous vehicle. Some futurists and whatever predict that, for example, if your child is not in school today, your child, for example, will not have the need to go for a driver's license test. I like that one, then I can keep my kids away from a steering wheel. If they are like me, boy oh boy, there's big trouble on their way when the grandkids are going to that same age. So, but that's, in real term, autonomous vehicles is upon us. You've seen it with the likes of Tesla, you've seen it with the likes of Google, you've seen it with the likes of Uber. All of them are investing heavily in that. We as well are investing heavily in that. So the flood is coming. And this flood is totally unstructured data. It's not traditional data, it is voice, it is video, it's photos, it's sensors. It is a lot of diverse data streams that we're going to look at. But on that list is one important one, and to get everybody awake after lunch and after coffee, let's put a bit of a smile on your faces. But why I brought this one in? We will have the largest data generator in the world here in South Africa. And that will surpass the largest one today, and I'll talk a bit about both later on, which is the Large Hadron Collider at CERN in Europe. The amounts of data that the SK will produce is tremendous. All universities, or almost all of them, are either involved in both those environments or in one of them, and the amount of work that you're going to do going forward is going to put huge challenges on your data center environments in the various universities. Now, typical, some of the challenges you will face is, there you see a whole lot of them. But you will have to do more with less. Yes, we have socio-economic challenges that is challenging the amount of money available that we can pour into data centers. We all know what that is, and that's not the point of the discussion. But can we do more with less? The absolute is definitely yes, and I'm going to show you a bit earlier on as well. Your data center has to become agile. And we're going to have a smile or two more around that scenario a bit later on as well. But your data center has to adapt to the moment's requirements based on the workload that it will have to process and the results that are going to be needed coming from that result. Now, let me put up your hands with the next picture and see if that is familiar in your environments. Single app, application, a server. An Exchange data mail server on a server. SQL database on its server. Everything's got its own server. Okay, I know it's not everywhere that bad, but it was a few years ago, and I see it a lot. Not only in university spaces, but even in enterprise environments where you see that. What I see in universities a lot is faculty-based environments. So what you can do is you can replace the application by a faculty. And then, what does that bring to the table at the end of the day? Let me give an example of the challenges that puts and the cost overruns that puts on the environment. Let's take, for example, people that's doing water type research environment in a university. Faculties that study dams, etc., all of that. And they use, for example, some kind of flow dynamic application to measure the speed water runs and how it behaves in certain environments. So now I'm just thinking wildly how to interpret this in a sense. But then also you have your engineering department, and they are looking at, let's say for example, aircraft wing design, where they use another form of computational fluid dynamic application, or similar, or perhaps even exactly the same one, but the university then starts to pay double and triple and 3, 4, 5 times for the same application because of the silo-orientated environment. Can we consolidate those workloads? Yes, but the problem is I get research fund for this, what I'm doing, so I cannot mix that in that environment. Those excuses are beginning to run out, and you're going to see what we're talking about. So in 2004, the drive to virtualization began. Yes, we all know VMware, Hyper-V, and what you have available, they are still very valid, but due to the demands of the data center, it's becoming a cumbersome program and project to maintain those environments. We need to speed that up, and industry has kicked in, and a lot of things has been going underway. And this is where we are heading today. Your traditional VM on base servers, etc. From there, we moved into the cloud, but now we move into the resource pool environment. And I'm going to talk a bit about that, and the term is rack-scale architectures. I don't know who has heard about rack-scale architecture and where it fits in and how it works and so on. Who knows the old mainframe environments? We're going basically almost back to that environment, but in an open architecture environment, and you'll see where we're going to do. But the important part there is we started with virtualization by extracting hardware. Now we're abstracting the data center. Brick and mortar is becoming software defined. Even your data center is becoming software defined. Even your data center doesn't have to be in the same physical spot anymore. Then you say, but hang on, how are you going to do that? How are you going to disaggregate the data center? And there's some innovative technologies that we've been working on that you will see. So this gives you an indication of the diverse workloads the data center has faced compared to traditional workloads. Let's look at a few of those. Data-driven. Yep, it's about the data. What value has the data? Data has to meet one criteria, one single very important criteria, and it has to have value. If it doesn't have value, then why are you keeping it? Maybe there's potential value. You don't know. Okay, let's keep it then. But then you see in the beginning how data is going to grow and grow and grow and grow. We're not talking petabytes, we're talking exabytes of data that you will end up with. And what value do you still have with that? It's costing you a lot of money to store that data. We need to work on that approach and get it going. And so we can go through all of that. It's about experiences. It's about innovation, real time that you will experience. So, and we had called it at Intel the virtuous cycle. At one side you have the data center processing data. On the other side you have devices, things, people like us. And it's a virtuous cycle around. Data center gives results back to you, you generate more data that's going back to the data center, and so the circle continues. An important factor is networking as well. Today's networks, today's 4G network is too slow for that. You've seen what a connected car is going to produce. How many cars are in Durban on the road, for example? 1 million, 2 million cars? If you have 2 million cars, about 1 million cars, let's say 100,000 cars, and each one generates 4 terabytes of data a day, that data has to go somewhere to be processed. How's the network going to handle that? These are some of the demands and challenges that a data center puts into place. So 5G, the next generation network, is alive and well, and we are working on that as well, but I didn't bring that into this discussion. It's too much to discuss today. To transform your data center, you can look at 3 basic steps that you can look at. First, performance management through virtualization. That's very important. Not silo-based structures anymore, like faculty-based or application per server, but you integrate all of that into a single domain. And then what you then do is you run a software-defined infrastructure solution on top of that, like OpenStack, for example, where you can get away from virtual machines going to containers, but with proper security, for example, that underlie those containers as well. And then create greater value. If you can't create value with what you do, then why are you doing it? If it's costing you more than before, then you're on the wrong track. So it must create value, and it must drive business innovation. How did you previously in the past, if you look at the cycle from a traditional application, from idea to go live for a solution, was a long process. It took months, and you had to go through all of that. By going with the software-defined route and start looking at new innovative ways to do that, you can do it in minutes. But then you also require the right technology. And what we've done at Intel is we've captured all the right technologies in order to do this in what we call the Scalable Systems Framework, SSF for short. We at Intel, we love our acronyms. We can hold discussions in acronyms. That's how many we have. We actually have an acronym app. You can go and download it from your app store, the Intel acronym app. And you can see there's literally thousands of them. You can do a conversation in that. But what does it entail? What do we try to achieve? Multiple workloads, doesn't matter what it is. You can look at modeling and simulation, like I mentioned, CFD type environments, heavy and tense, ANSYS, those type of applications, that's heavy compute intensive. To data analytics, big data, high performance data analytics, what value can you derive of the data? Artificial intelligence, I'm going to talk a bit about that later on as well. Or visualization. Visualize what's going to happen with predictive analytics, etc., all of those things that you want to do. That framework will be able to, if it can handle those diverse workloads, the more common ones just slips in between those cracks and fits into make the picture complete. Scalable system framework consists of 4 areas, and I'm going to talk about 3 of them. One is compute. State-of-the-art Xeon CPUs, you know them fairly well if you are a data center environment. Xeon Phi massive parallel processors and co-processors. FPGAs, actually an old technology that's becoming very new with what we've done with since our acquisition of Altera. FPGAs were notoriously difficult to program. Now we've brought it to OpenCL. You can now program FPGAs with OpenCL if you use Intel FPGAs and the Intel compiler suite. It's becoming very easy to do that. Those type of accelerators is important to accelerate what you're doing in a data center. Then storage. Who have you heard about 3D XPoint? You all know DDR memory. You all know it's damn expensive. And if you need massive amounts of that, the memory costs more than your data center almost if you have to populate a large platform with a huge amount of memory. So I'm going to introduce you to a new type of memory. It's actually the first new type of memory in 30 years that's been created. Come to think of it. It's a long time that uses memory, not storage. SSDs are storage. DDR memory is around for a long time. Now 3D XPoint is a new memory, but associated with that also is 3D XPoint-based storage, what we refer to as Optane. The first SSDs has been launched and is available now, and it is tremendously fast. Then the software EcoStack. You heard me, I mentioned OpenStack, the Intel compilers, there's the Intel file systems, there's a whole lot of other software that fits into that picture, and there's a slide coming up that will show you a bit around that, where that fits in. And then Fabric. That's your Ethernet, standard Ethernet, 10, 40 or 25, 50, 100 gigabit Ethernet fits in there, but also your switch fabric that you use. If you build large clusters, Ethernet is only good enough for up to X amount of servers that you bundle in a cluster. And if you go software defined, you will have to really look what you use for that environment. Those are the technologies that I mentioned over there in the software stack. But what I want to get about is the rack scale architecture. This is your legacy platforms that you have. We're changing that into where you go to a pooled resource platform going forward. This is what it looks like. Your CPUs, all your compute sits in a drawer, or a pod as we call it. All your storage sits in a pod. All your network connectivity, all your accelerator sits in a different pod. And this is how it typically looks. Is you have compute pools, hot, warm storage pools, etc., etc. And the way it works, this is traditional standard. When you have a workload, you allocate CPUs out of the compute pod to that environment. Storage you allocate to that, accelerators to that. The beauty of this is once the job is done, it goes back into the pool and it becomes available for somebody else to use. The ecosystem is alive and well, as you can see, and a lot are adapting it. And this is actually out of date already, this slide. That's how fast the ecosystem is adapting. You know the Xeon architectures, but the next generation Xeon processors becomes generally available on the 11th of July. The performance is tremendous compared to the generation that you will start replacing today, the V4 series. On a one-to-one ratio, you can scale, for example, in a cloud or a virtualized environment from 148 to 692 VMs. Or if you want to stay with the same amount, you can consolidate on a ratio from 4.6 to 1. That gives you an indication in the jump in performance and capabilities of the technology. Silicon photonics, new way generating laser out of silicon instead of an emitter, and there you can see the distances you can travel with it. So your campus can become your data center, not the building, your whole campus, and even if you have multiple campuses. Spoke about 3D Optane. That demand drives access to faster memory technologies, and the Optane technology, the 3D XPoint Optane SSDs and the memory modules sit there. And I said it's a new memory technology. It sits between your storage and your DDR memory. That is the Optane SSDs, and this is the memory modules. And you'll see some interesting numbers down there on how long it typically takes to load a SAP HANA database. I cannot disclose the number that it is over here, but it's a few seconds to get a SAP HANA database up and running from literally minutes. And then the next killer app, artificial intelligence.
We're designing the store. I'm in the future. It's
Yeah, the last bit.
The streaming we can't
Never smart about trying some new clothes. But I can't find anything. Well, in the future, every store is designed by customers. Intel uses the data to help retailers make sure everything's where it's supposed to be, optimize the inventory based on what customers are buying, anticipating trends. In the future, your store can be a lot smarter. I should look into that. Oh, you do. It makes you very rich. It's going to make me very rich. Yeah. What else can you tell me about the future? Skydive. Don't do it. We know the future.
And to close off that picture, I mentioned it. Is it HPC? Is it big data? Is it both? Or is it a good use case for artificial intelligence? Why? You don't know what you don't know. And how do you know what you don't know? That's why artificial intelligence is becoming very important. It's alive and well in those areas. And to close off on a lighter note, we bring back for Jim.
There's an app for the glove box. Okay. But why would I need an app? We know the future because we're building it.
Thank you very much. I hope you enjoyed this quick snapshot in the data center of the future.
Thanks, Hannes. Unfortunately, there's not time for questions. We're running late, so if you want to go to another session, quick change over, please. The people outside can come in for the next session. You're welcome to come in. Anybody changing, please, please, please. Now, we're running late. Okay. Testing. Okay.
Testing 1, 2.
Okay. Are they going to use this mic? This? They're going to use this mic. That mic's useless. That's it. Yeah. I see we've only got Charles, so he's obviously the star of the show. But I'm going to leave it up to him to introduce his team who are co-presenting. Sorry, technical glitch. Okay, CPUT, let us know what you learned from Fees Must Fall. We can't wait to hear.
Good afternoon, everybody. Thank you very much, Val. As we get settled down, we didn't know we do expect a small or large audience, so we're hoping you guys will work with us as we go through this. And let's start slideshow. Yay, it works. Okay, cool. So, as indicated, I don't think we're going to use anything that fancy a minute. As indicated, these are myself and colleagues from CPUT's CTS department, the operational IT department. There are 5 silos or 5 teams within that particular department. So there's one from each one of those 5 teams here. I think the only person or the only team that we skipped was the admin support. So they're not represented here today. But for those of you who are really bored and want something to do, there's 1, 2, 3, do we say 4 campuses? 4 campuses, no, visible in this picture. Right, so, yeah. But we'll get to that. That's the good stuff. So, this is our topic for the day. Ta-da, welcome, and we hope you're gonna join us with lots of questions at the end. Just a little bit about CPUT if you are new to who we are. Just a couple of key things to put things in context for you. So roughly 35,000 students, of which we have roughly 2,000 staff. This excludes people like the examiners, the part-time people that join us from time to time for certain periods like registration or graduation. And then, of course, out of that 2,000, we only have about 80 people in the IT department. Apparently, our ratio is 1 to 450, roughly, around about there, when it comes to IT personnel to staff. And then, if you really wanted to know how spread out we have about 6 campuses and 4 service points. Those 6 campuses range from Cape Town's foreshore, where there's a hotel school, all the way up to George, where there is a nursing college. Okay, so we're pretty widespread, and some of those 80 people actually need to cover that entire ground. Okay, so now we're going to hand over to some of the sessions and some of the sections, excuse me, and I'll let each one of the colleagues introduce themselves.
Thank you. Hello, I am Vanessa from the Strategic Administration Services. I represent the service desk specifically. Lend me your ears and I'll try to minimize yawns. Right. During the whole fees must fall debacle / dilemma / other dramatic words starting with the letter D, the main thing that came to the service desk specifically was working off campus and the whole concept of a mobile service desk. So imagine a person sitting behind the desk, wheels on the desk, wheeling around, going to everyone saying, have you switched it off and tried putting it back on again? Oh, joke is gone. Anyway. Yeah, the main challenge we faced was getting out of the idea of that desk mindset and having all of your software and your applications at the desk. And we had to work off-site, from home, from our phones, from laptops, wherever we could to assist people. And one of the main things that the section was very proud of was our web-based incident logging or call logging mechanism, which we use Heat, purely web-based. It's filtered through amongst the other teams as well. They also make use of it. Accessibility was a bit of a schlep initially because the access was limited to our on-campus network as opposed to being just purely web-based where you access it everywhere and anywhere. But through the help of the other teams, that was quickly moved over and we got over it. And although most of the processes, we're very process-driven, policy-driven, and it was difficult to maintain that because you're not on campus, you're not in your normal environment. But being that we were so policy-driven, we still abided by those rules and regulations and still logged everything that we needed to log. Right, now, the ordinary tasks and functions that we performed had to be streamlined. We focused primarily on access to emails, to communication, and one of the main things that we encounter daily is people forgetting passwords. It's a common thing, or perhaps they had their password written on a little nice post-it stuck on their computer or on the monitor, but now you're at home or you're in another place altogether. Where is your sticky note now? And so they obviously called, emailed, WhatsApp, smoke signal, whatever they could to get their passwords changed. And it was also difficult getting people over the mindset of accessing your Outlook mail just through the software or the application installed on your system. And getting them to use the website, getting them to access the emails in another manner as opposed to what you're used to. People are resilient to change. Everybody likes to preach that they are fine and comfortable with it. But when it comes down to it, it's like, oh, do we have to? Isn't there another way? Can't we just bear the brunt of the students and go to campus? No. I've got a little screenshot of this wonderful thing. This is just a simple password reset tool. But the bulk of my day is spent on this little block, typing in usernames, student numbers, changing people's passwords. I'd like to consider myself multifaceted, but I'm really just a password changing machine. Yeah. Now, more dramatic words, realizations and revelations. I've got some stuff that I've mentioned already on here, but I'm going to go to the last point. The fellowship, that almost sounds like we're taking the ring to Mordor. But it was a difficult time, and what comes to mind to me was during the Fees Must Fall, the whole thing that went down, on the morning, we have this group chat, and some pictures were sent through on the group chat of the destruction that was happening on one campus specifically, the one that most of us are based on, except Keith, on the Belleville campus. And we have this grand entrance of these huge gates, and it was always nostalgic for me taking a taxi to work and walking through these gates, because I studied there as well many, many years ago. And I always enjoyed the walk from those gates to my office in the IT center. And these gates were on fire. It was destruction and demolition. And I'm not one easily fazed by, I don't try to let emotion run me, but we are all sentient beings and we can't help but being governed by emotion. And I burst into tears looking at these gates on fire. Where should I walk to now? What happened to the geese? There were lots of geese on campus. And the people, or the staff members, all of us, colleagues, it was a sentiment shared by everyone. It was difficult, but having all of those people there, still soldiering on and getting the job done and performing whatever's needed of you, and having that support structure was great as well. Well, it was more than great. It was the only thing that we had at the time. And in our IT department, we like to look at ourselves as separate entities within a bigger entity. But at that time, we were just one big mush, for lack of a better word, only one syllable this time. And that was what we gathered from there, and we were a stronger group, we were a stronger entity after it. Obviously with the rules and the paperwork put in place, like should this stuff go down again, this is what we're going to do, we'll be more prepared and such. But yes, that is my shared experience with you guys. I will hand you over to my sister in arms.
Hi there, I'm Tammy Hercules. I'm from the Business Administration section. We are the custodians of our ERP system and provide access and support to our user on our ITS system. During Fees Must Fall, we were basically the coordinators for the users to ensure that they had all their ITS needs fulfilled. We made sure that laptops were handed out and Wi-Fi modems were given to the users as well. And if they needed to access remotely, then they would ensure that the network section got their access requests. During Fees Must Fall, we had secured 2 venues, and at these venues we had 3 areas sectioned off for different functions. The first area was for our business critical functions, and that could be our HR, our creditors, as well as payroll. Our other section was the applications and the registration, where they uploaded our paper-based application forms, even though we did have online applications rolled out that year, but there were some students that still did the paper-based approach, and they loaded on our system. And the last section is where we were very actively involved in, is our business acceptance testing, where our ITS users tested our ITS system to ensure that there were no issues for the 2017 registration. Our ITS system normally works quite seamlessly on our environment. All that the users needed was Java to be installed, as well as have the proper internet setups. And our interaction with our users on a day-to-day basis is normally very impersonal. We just call them on the phone, via email. But during Fees Must Fall, we had the face-to-face thrown into the deep end, having to have 60-odd users demanding all the attention of us limited staff was a bit draining. During our back testing, as the user discovered some issues, we had to ensure that we contacted our vendor, but it was quite difficult to contact them from the site because it was quite noisy. So all the interactions had to be done via email, and getting them to understand lots of what the users want to have explained and changed and updated was a bit difficult. And we had quite a few users, because we had limited space, work remotely. And our section really relied on our users to be a bit tech savvy, to be able to install TeamViewer for us so that we could remote into the PC, set up the VPN, and ensure they could get into ITS. When we also discovered that when trying to log in with VPN, that our test and our production environment could not run simultaneously. And our network guys sorted that out, and everything was fine after that. During Fees Must Fall, access to our ITS system, or any updates to the access to the ITS system was a bit difficult because of our processes we had to follow, procedures we had to follow. We could not grant the users access because there was no proper authorization given. And one of our biggest fears was our servers. Buildings were being burned down, and we were worried that what if they target our data centers? So just having that fear, everybody was talking about we should move this off-site. So there was talk of that, but eventually the Fees Must Fall ended and we were back at work. The lesson learned from our experience is that in our sections, we have got our 5 sections, but not everybody was on site. And better communication within our sections could have prevented lots of our issues. And our staff were very versatile. Everybody was there. It wasn't one person was doing one section's thing. Everybody was helping everybody else. We were all hands on deck. Our online access model is being investigated now, so that if users need access, we can have users get authorization from our HODs and data managers, and they can keep track of their own access as well. And the last thing is to be prepared, or be prepared as possible. Because in a situation like this, you will find a hiccup here and there. Nobody can be 100% prepared. There is a saying that goes, to be prepared is half of the victory. And I can say that our team was victorious during this Fees Must Fall.
Hello everybody, I'm Joshua. I'm representing the network and internet section of the CTS department. Just so that you know that, like Charles explained, yes, we have 6 sites, but there are probably 20 other sites that is not really mentioned. So we're more like 25, CPUT consists of 25 different sites. And in our networking department, we are about 7 or 8 guys that have to do all of this from Cape Town through to George. So you can imagine it's a 5-hour drive through to George. You need to do something over there, 5 hours up, do your networking issue, 5-hour drive down. So just to put into perspective my department. What was our involvement in the whole Fees Must Fall issue? Well, firstly, when our campus was shut down, we had to ensure that all staff members gets moved to some remote site, secure, and we need to set up some type of local area network there. We need to ensure that all these staff members are interconnected, there's printing, and just local area network. But secondly, more important, that remote site needs access back to our enterprise site, because that's where all our information sitting, that's where the servers are running, the facilities, that's where the data center is. And then thirdly, what we were responsible for is that this entire setup that we do at this remote site needs to be dismantled and moved efficiently and effectively, and at times by tomorrow this entire thing needs to be set up at a different location. We were at a location, Stikland, and we were told, guys, the site is not secure anymore. By tomorrow, the day after, everything needs to be moved. The entire site needs to be moved to Wingfield. Network needs to be up and running in the next 2 days. Right? So you can imagine the challenge it is for us as not just the networking, but the desktop support guys. They had to move all those machines, all those printers. Right? So like I said, the most important thing, or the more important thing, was ensuring that this remote site connected back to our enterprise site. And we used 3 different methods to do this. The first one was we used VPN routers. I don't know if you can see in that little picture over there, that what we, okay, just press in the middle, and then, okay, there we go. Okay, so I'm going to have to come over here. Okay, so our main focus was getting this remote site connected to the corporate site or the enterprise site. That's where everything important is sitting, right? And we use 2 types of routers. We use the Cisco 887 VAG, and basically this is a router that we use with a Vodacom SIM card as the internet connection, and that created a VPN tunnel back to our network. The second one that we used was a Viptela VH100. That is the Viptela, and that is the Cisco router. The Viptela, same thing, using an ADSL line this time to route back to our network, and from there, what we basically did, connect that thing up to a switch, and then have the LAN run from the switch. But from there, that thing was gold, getting everybody connected to our actual enterprise site. One shortfall that we experienced during the setup was this. The SIM cards that we used in the Cisco router was actually capped Vodacom SIM cards. So 20 gigs for a week for normal work should be sufficient for 50 users. But while people were working, we walked through the remote site, and we're seeing people on Facebook, and some people have YouTube next to the work that they're doing. And at one point, people are working, and then, choom, everything just goes down. Nobody can connect. No emails are coming through. Printers are on pages are not being printed. What's going on? We troubleshoot. We find out that the data is actually being used up by the YouTubers and the Facebookers. And there was a lot of, I wouldn't say a lot, but there was some paperwork involved just to replenish every time that data, because it was a bit difficult to control what the people were doing. Yes, we told them, but you know, people want to listen to music or watch series while they're working. So that is the one method we use to route people back to our network. And the second thing was that we used software such as the Checkpoint client. Right, that one over there. I like this laser. It helps a lot. Right. So we actually use the software client, because what we found is that, like Shaul showed in his slide, that we have about 2,000 users. Can you imagine moving 2,000 users to a remote site and getting everybody set up? So what we had to do, we had to prioritize our users. Who needs to work at the remote site? Who can work from home? And that's what we did. Those who needed to work at the remote site, we got our router set up for them. For those who can work from home, our admin staff, we installed the client software. They could use their own internet connection and then just use that and VPN back to our network to access the resources there. For those who did not have internet connections, we partnered with our telecommunications department or section, and they provided Vodacom dongles for each person so that they could have internet at home just to get done with the work. Yeah, so speaking about the prioritizing, we found that during the Fees Must Fall, there came a very crucial time that we had to prioritize our who got access to the remote sites. And this was just before payday. We wanted to get paid, so we prioritized our salaries department. Everybody else, you'll have to wait. Salaries department, you get your butts to the remote site, you sort out that salaries, and once the money's in, okay, it's cool. Everybody else can hop on, right? And then the third method we used, once we found that Stikland wasn't secured, we moved everybody to the Wingfield, which is actually a military base. And we felt quite secure there. And we found that, okay, we felt that if this venue is secure, why not just set up a wireless link? Why not partner up with one of our service providers? And that's what we did. We spoke to Tenet, and Tenet actually spoke to a company that was quite close by, which is T-Systems, and they set up a wireless link between Wingfield and T-Systems. And then through T-Systems, we could actually just route back to our network. And that was actually quite a help. So that was our main involvements during the Fees Must Fall. And when I was told what is the topic of this talk about, it's lessons learned, the very first thing that came to my mind was the words of Bruce Lee, "Be like water, my friend." And it speaks about adaptability. And I think that we in the IT industry, we know what it's like to have technology rapidly advance, and you just have to advance with it and adapt with it. And that is the lesson that I learned, that the Fees Must Fall thing, it happened so quick that next week we are told campus is shut down, we're moving everything to a remote site, everybody, all hands on deck. And there's no time to plan now, there's no time to get everything ordered, it's just adapting to the situation that you're in. And that is what I learned in Fees Must Fall.
Hi, good afternoon, everybody. I'm Keith Collide. I'm from the end user computing section. We primarily look after desktop environments, back-end Microsoft environments, and printers. Some of the challenges that I picked up during the Fees Must Fall was the lack of support staff. They basically yeah, during the Fees Must Fall, there was initially a lack of support staff because staff didn't feel very convinced to come to site because there was no guarantee of our safety. And something that I also noticed, our first two sites that actually went up was Stikland and Wingfield Military Base. They're supposed to be secured sites that we noticed. When we got there, noticed there was not a lot of planning that really went into this whole exercise because this is something that we were never prepared for. And other challenge, transport. We were expected to go to campus with a CPUT branded vehicle to go pick up equipment and bring them to the remote sites. And some of our guys actually volunteered to actually do this. And the other thing also, they expected us to report for duty at the campus and get transport from the campus to the secure sites, which I thought wasn't a good idea. I actually suggested to my manager that I'll rather go with my own car to the site. And infrastructure, on these sites, like at Wingfield, we used the old air hangar. There was no infrastructure at all. So when we got there, one of the things that also made it, even there was no planning, we arrived there at the same time the people we were supposed to support. And there was nothing, no power, we had to set up everything while these people were standing there expecting to work immediately. And hardware, since most of our staff actually use desktops, and all these desktops were on campuses, and people couldn't go on campus because of things that was happening, we rented about 250 laptops, and we also procured some laptops, and we had to get our printer vendor to actually go on site, or actually convince them to go on site to get some of the printing and bring it to this secure sites. And with some of these laptops, with all the laptops that we rented and procured, there was no asset tracking. So when these laptops arrived, they would just dish out to staff, not marked or anything, who took what. And we ended up with a situation where 20 of these laptops went walkies. And software, since we rented these laptops, none of these laptops had any CPUT software packages or anything on it. So we had to make sure that all the software get onto these laptops. So the only place where we could really do this was on campus, because doing it off campus was a bit of a challenge to deploy images to 250 laptops. I personally was involved with the deployment of the software, where we actually went to Grangebury campus, the one behind Cape Town campus, behind Cape Town Stadium. And we worked about 4 o'clock in the morning, deploying images onto laptops. And email, just prior to the fees must fall, a lot of our staff started running out of mailbox space. And it was decided that auto-archiving must be enabled, which used to be an option. And most of these people's emails started getting archived to their local machines, and then fees must fall happened. And when we were on the site, people couldn't access their email that they archived. So that became a problem, and our mail server was also starting to run out of space, and the guys couldn't go on site to actually go and see to the server. And data access, with a lot of the staff having the data on their machines in the offices, there's a problem getting to these data. So we had 2 of our colleagues that was brave enough to actually go to the finance department's offices belonging to each person's machine and get their IPs and make sure that the remote was working, so that the staff could actually remote from one of the secure sites to the machine. Okay, and solutions. Since this, the fees must fall, a procedure document has been compiled in the event something of this nature actually takes place again. And hardware, we actually preferring procuring laptops instead of desktops, and phase out desktops to staff, because in the event something like this happens, staff can just take their laptops to whatever site they need to go to. And asset tracking, what we do with most of our IT stuff, we actually get the suppliers in conjunction with our asset department to pre-asset tag all our equipment before it actually leaves the supplier site. And software, with all our new laptops, we also get our suppliers to pre-install all the most important software that most of our staff actually use. And email, since all our students' email accounts already and in the cloud, we're in the process, we already started moving all our staff email to Microsoft 365. And the other thing with data access, we're actually in the process of trying to force all our staff to save their data to OneDrive instead of saving it on their machines. In the event something like this happens again, so that they got access to their data, so they can work from wherever, or on portable drives. And something else is also, but the data centers, initially with the fees must fall, protesters were targeting like finance department, thinking now if they burn the finance department out, they'll destroy whatever information is there, not knowing about the data centers. But now, we attended a meeting recently where they actually indicated that we're actually in the process of maybe moving our data centers off-site in the event our data centers get attacked. Thank you very much.
I shall try not to feel offended by the fact that I do still have a sticky to tell you guys about. Or maybe Keith is just so good that he needed his own little short little hand clap. So as I said, my name is Charles. I'm a representative of that fifth team that we call ISF, Integration Services and Facilities, which means we are basically the hosting guys. We used to be the Unix team as well that used to look after the mainframes, but we're now moving into the hosted space. So CPUT provisions via this team, whether it's virtual or a physical machine. So because we did not know how long it was going to take for us to get to that particular point, I am going to tell you a bit of a story. Okay. So my story is about princesses, castles, and dragons, right? And as with all good parenting, it starts with what your grandma tells you, and that stays with you for the rest of your life. So princesses in this analogy would basically be all of those requests and demands that are getting made on our particular team. Part of the problem is that we believe all princesses look the same. So often, if somebody asks you for a particular service to comply with a particular thing, we believe they all are fundamentally the same, but we miss all the differences that they might be. This was something that was very much brought home to us during Fees Must Fall when we were moved out of our comfort zone. And I have to admit that of the 5 teams within CTS, the ISF team was one of the quieter teams because our data centers did not actually go anywhere, not at that particular point anyway, right? So it was critical that there be support for the users. It was critical that the links be reestablished. And we had some other additional problems with fulfilling all of these requirements. So just when you think you've got it all sorted out, you've got a blockbuster on your hands, there is, of course, a requirement for a repeat performance. All of the things that were said by my colleagues today were about both Fees Must Fall. And for CPUT, Fees Must Fall was very different in 2015 than 2016. We were of the opinion that we had more or less had the problem licked by the end of the 2015 incidents, and then we had a very late and extremely violent Fees Must Fall in 2016. So, you know, just because you think blockbuster number 1, done and dusted, does not mean that there won't be a need for a number 2. So let's talk about castles. So there is iconic castle imagery that goes with this particular thing. So I'd like to associate our data centers with a particular castle, with a keep, with a fortress. It's a safe place. It's a place where your resources are housed. It's a place from which there is a sense of you govern from here. So it's also a political tool, and actually because of that, that is the reason why we started suspecting that the students were getting more and more serious about making a very serious move against one of our data centers. We have a distributed policy at this particular point in time, so some of the services actually run off at our remote sites, and as our Tenet infrastructure is getting more robust, we're actually folding them back into 1 or 2 larger data centers on some of the larger campuses. So there are lots of risks to manage for a particular five-person team. So the idea here is that we need to turn our idea of what this castle, what this keep is, on its head a little bit. You've heard the gentleman from Intel kind of give you the Intel view of what's going to happen in the future. So I hear people kind of, and this is all the buzz now in IT. And I mean, in IT, we love the fact that we've got new toys to play with. But we have also learned that particularly because of budget constraints, we need to make our solutions fit for purpose and something that we can afford, right? So we know that, for example, the CPUT data center would never reside fully in the cloud, right? There are all sorts of implications. There are things that indicate to us that bandwidth would still be a problem. And all of these things play a part in what the user or the end user experience actually in the end is. So while we are way, way, way in the back office, some of these things do become a concern to us when we start generating, when we solve one problem, but we start generating new problems in a new area. So it's very important that we start looking at what we do and why. Okay, so the question is posed here that, is this the perfect castle? Somewhere in the cloud, you know, flag waving, happiness, Disney, it's all good, you know, it's like little twittering birds as we sing hi-ho, off to work we go. I don't think the matter is settled yet. We are now seeing global trends where large companies that were early adopters are pulling workloads back out of the cloud again to run them locally, right? So there seems to be that standard push-pull between decentralized or away and then stuff that you want to have centralized and or local. That seems to be a trend. I cannot tell you where CPUT will end up, but I can tell you that this is a bit of a journey, right? So we are on this journey and we want to make smart decisions as we go. Right now, there is not one single decision that fits. Okay, so not dragons. So dragons, metaphorically, in this kind of sense, are, well, they can be malicious, so there is fire breathing, but they're more or less benevolent. So I'm talking about the monster that you need to manage when it comes to your data, whether you're warehousing, whether you're backing up, but just that data that you manage and back up. In Feesmos 4, for example, we have an audit workflow that says that we have an off-site repository for some of our data, right? Now, if nobody can get to the tape library to eject the tape, the third-party company cannot get on site to come and collect the tape, then after about a week or two, we have a problem. You know, we have a severe problem, and the risk that we are exposing ourselves to becomes greater and greater. So those of you who were in the Microsoft workshop yesterday, and I know similar services exist for guys like Amazon, we are seriously considering doing a trickle feed now into some sort of storage pool in the cloud, right? That is something that we are seriously considering, and it's something that we are taking a very, very serious look at. So that's gone very fast. So if there are any questions, we are listening. If you are very tired, sleepy, and or ready to go home, no questions? Ah, okay. One question.
Hi there. So I'm from UKZN. We've got 5 campuses. I see here you've got 6 different sites. What about having a backup? Do you have a backup policy where we try to save everything on different sites? Like
yeah. So part of the problem that we have here is, in usual business continuity terms, we had a fairly mature way of dealing with backups, recovery, that kind of thing. So we would have what we have, because we're a merged institution, right? We have 2 rather large sites. The one can be the mirror for the other, which is what we did, right? The situation that we found ourselves in is, all of a sudden, all 10 of our sites became toxic. We could not touch them. Not for flood or fire or any other natural calamity. It was politically that they became toxic. But we still have to mitigate against the risk of that data loss, which has now become something internal. You know, somebody who might have access, you know, that to at least breach a first layer of security. You know, they are allowed to access the building, but you know, if there's a Molotov cocktail in there somewhere, you know, it's like. But by the way, we are also kind of have our data centers fire rated, so that's, you know, that's okay. But you know, there's all sorts of other damage. One of the things that concerns me particularly is the fact that I am not sure that we have taken sufficient steps to protect ourselves internally from hacking. So the firewall sits beautifully there and it kind of blocks off all our sort of outsiders, but anybody that has access to our computer labs, all that kind of stuff, actually does pose a very, very, very severe risk. Okay, so I'm hoping that answers your question. Okay, anybody else? Everybody wants to go home. Thanks, Paul. Ah, there's one. Hey. Okay, so the question is about staff morale and how we dealt with it. We have had endless discussions about what we should leave out and what we should put in. But you've asked the question, so let's address it. This is one of the shortcomings that we have found at the university. The problem is there'll be a crisis meeting with a select group of people, and then because there is an unknown threat of an unknown size, information does not get disseminated in the normal way. I'm not sure about other universities, but our processes are procedure driven, but we function via bush telephone, right? I know about something that happened because you told me, and somebody told you. You know, and eventually, a half an hour later, the entire university campus knows, but that's how we genuinely spread messages a lot faster than we could have emailed it out. So communication is still a big problem. Morale was a problem before Fees Must Fall. It is extremely bad right now, right? A few things have happened to improve the situation, but the communication was lacking. It's acknowledged as having been lacking. There's supposed to be processes in place to improve it. What has been fortunate, for example, for the CTS department, and some of the colleagues have alluded to this, that rallying around has actually done more for team building within our IT department, for example, than, because we now feel like a cohesive unit, right? Or more so than we did before, than any of the fancy exercises that we did with some HR expert before. Okay, thank you.
Anybody else?
Thanks, Will.
Right, give it up for CPUT. Thank you for your brilliant presentation. It was really good. That brings us to the end of this stream for the day, and I hope to see you all at our event this evening. Bye.